All right. Next on our list, we've got function composition. Function composition is a way of embedding one function inside of another. We're going to be taking one function and inserting it or plugging it into the other function. This is a very important tool for calculus. It's pretty straightforward. Sometimes the mechanics of it are kind of tedious. There's nothing complicated here. There's nothing you haven't done before. So let's get this party started. So let's see. First off is how this is written. And I know I made a big deal about this. What we're doing here is naming a new function. F of g. Now this is not an O, it's not a 0, it's just an open dot. It's defined like this, which may not be very meaningful to you because I know there's a lot going on. I'm going to make these parentheses a little bit bigger. And what does this normally mean? If I have f of something, like for instance I ask you to evaluate f at some point, like for example if I ask you to find f of 3, what am I asking you to do? I'm asking you to take 3 and plug it into your function. Plugging it into f wherever there's an x value. We're doing the same thing here, but we're taking another function and plugging it into f. So, at least the order is very, very nice here. You're always plugging in the thing on the right, you're plugging it into the one on the left. So f of g. Technically f of g of x. Yeah. Well, so we're gonna. Sorry, I lost my train of thought. So we're gonna take a function, plug it into the other. That gives us a new function, which we can then evaluate however we want. We can also go the other way. We can do g of f. Again, you could actually do whatever you want. Once you've got this kind of operation defined, we could do any kind of crazy combination. We won't in here, but there's no reason that you couldn't have like f of f. Why not? Why can't I plug a function into itself? Perfectly fine operation. You could actually do multiple combinations. I could do like f of g of f. You know, something insane like that. So it's like we've defined a new operation, like addition, subtraction, etc. And this one means insert. Okay. So our first example, find f of g of x, and we're given f of x is 2x plus 4, g of x is 3x minus 5. So what do I like to do? I like to rewrite it just so I can remind myself what's going on. I'm taking my second function of g and I'm plugging it into f. Oops. There we go. G. I'm going to include the x. Why not? If you don't like that x, just don't put it in there. You know, if I can be lazy like I was up here and just write the function name, you could do it too. You could just write f of g. I'm completely okay with that. Same thing. It's just f of g. If that makes it clearer to you what's going on, if that second x is scaring you or throwing you off or anything like that. So, what are we doing? We're taking our function g and plugging it into f. Well, g is 3x minus 5. I'm going to take that and plug it into f. And when I say plug it in, where am I plugging it in? I'm plugging it in where there was an x, or where there is an x in f. So I always like to write my function. So since I'm embedding it into 2x plus 4, I'm going to write 2x plus 4 without an x. I'm just going to leave a space there. So 2 blank plus 4. And then what was I plugging in for x? I'm plugging in 3x minus 5. And then I can distribute my 2. 2 times 3 is 6x. 2 times negative 5 is negative 10 plus 4. and then I can combine my negative 10 and my positive 4 to get a, negative 6, and carry down my 6x. So there's my new function, f of g of x. So I know it's kind of weird. Plugging x's in for x's. That's why I really like this first step, where you don't write down any of the x's of the function you're plugging it into. Because I know it's just kind of, it's a kind of novel concept to plug a function into another function. So part B, we're going to do the same thing, but with g of f. So g of f means take f, take that second function and plug it into g. Again, if you don't like writing it with x, you just write g of f if that makes it easier for you. So again, I'm going to write my g function, which was 3x minus 5. I'm going to write that with no x in it. I'm going to write 3 times blank minus 5. And what am I going to plug in to that function? I'm plugging in f. And f is 2x plus 4. I'm taking 2x plus 4, and this time I'm plugging it in. So now it's 3 times 2x plus 4, and I'm going to distribute that. It's 6x, and 3 times 4 is 12. I carry down that negative 5. And again, I can combine some like terms. 12 minus 5 is 7. And there we have it. Doesn't feel right about this. Could have sworn. Oh, never mind. No, this is fine. Yeah, this should be fine. Okay, and again, that's a new function, g of f. Okay. Finally, I'm going to take, in this last problem, it asked me to evaluate my function at negative 2. And I'm evaluating f of g. So I'm evaluating this first function we found, f of g. I'm evaluating it at negative 2. So that's why it's nice to have a name. We can refer back to these functions later. So we're referring back to it now. So instead of having an x here, what does it mean to have when I have a number there in place of my variable? Well, it means plug in that number for x. So pretty straightforward. I'm taking 6x minus 6, and I'm plugging in negative 2 for x. So now it's 6 times negative 2 minus 6. That is negative 12 minus 6. And negative 12 minus 6 is negative 18. Yay, we did it. Okay, now I want to look at composing two functions, one of which has a square in it, aka a quadratic function. So first I'm being asked to find f of g, so plug g into f. In order to do this, I'm taking g and I'm plugging it in right there where that x is. As usual, I'm going to rewrite f without an x in it. So instead of 3x squared minus 2, I'm going to have 3 times blank squared minus 2. And I'm plugging in 2x plus 5. So I'll plug in 2x plus 5. All right, at this point, order operation says that we need to... Ooh, my mic was too far away. I hope y'all could hear that. Our order of operations says we need to square this first. And to do that, you probably want to write this as 2x plus 5 times 2x plus 5. And after we've FOILed that out, then we'll multiply by 3, and then we'll subtract 2. But to start with, I'm just FOILing that out. Of course, there's a formula for this. Anytime you square a binomial, there's a nice formula for it. That's okay if you don't know it. I'm just going to FOIL this out very quickly. My first term, 2x times 2x is 4x squared. My outer term, 2x times 5 is plus 10x. My inner terms, 5 times 2x is plus 10x again. And my last term is 5 times 5 is 25. All right. I want to go ahead and combine those middle terms. 10x times 10x, or plus 10x, is 20x. I mentioned a formula for this. That is the formula. You square the first term, you square the last term. The middle term, you notice it's just 2 times 5 to get 10, and I've doubled that. Because the outside and the inside terms from FOIL are always going to be the same in this case. So you're going to have, you could just take 2 times 5 to get 10. You could just multiply that by 2 to get 20. So you can skip right to there if you want to memorize another formula, but you don't have to. All right, now that I FOILed it, then I want to distribute that 3. So I FOILed it, and then I simplified it. Right. Then I want to distribute that 3, and then I'm going to subtract 2. So I distribute 3, I get 12x squared. 3 times 20 is 60x. 3 times 25 is 75. And then finally I have that minus 2. Not a whole lot to do, just 75 minus 2. That's the only thing left to simplify, and that is, what, 73. So I've got my final answer, 12x squared plus 60x plus 73. Left off a bunch of equal signs, but that's okay. And that is my new function f of g. I always like to write that again at the end, just for reference. That way, if I'm asked to actually evaluate this at some number, I can do that. I've got a nice handy formula. I don't have to look everywhere for it. Part B, I'm going to do the same thing, but in reverse. I'm plugging f into g. This should be a little bit nicer. When I'm looking at g, it's just 2x plus 5. So I always like to write that, instead of 2x plus 5, I'm going to write it as 2 times blank plus 5. And I'm plugging in the f, which was our 3x squared minus 2. So I'll just throw that in my parentheses. 3x squared minus 2. This one's going to be much nicer because I don't have to square anything. It's just x squared. I don't have to evaluate this any. I'm just going to distribute my 2. So 2 times 3x squared is 6x squared. 2 times negative 2 is negative 4. And then I carry down my plus 5. From here, negative 4 plus 5 is plus 1. And I carry down my 6x squared. So it was much nicer, so because we didn't have to square it. So when you've got a quadratic as one of the functions you're composing, sometimes that can be a real pain. You'll have to FOIL. Sometimes it's really easy, just depending on which direction you're going. If they're both quadratic, well, that's another story.